Hi all, welcome to my channel ML with Munazir. So I just wanted to introduce myself a bit before starting this data science project. So I am a senior data scientist working at cybersecurity company, and prior to this, I have worked with multiple companies in telecom domain and in services domain. So I have extensive experience in developing data science related solution. So the idea of this YouTube series is I see that a lot of newcomers are struggling and their resumes does not have much content and much project in their portfolios. So I keep getting daily almost more than 20-30 messages on my LinkedIn inbox wherein people wants some kind of guidance from me. So I thought what I will do is I'll create a YouTube series wherein I'll be coding different projects, and I'll pick some basically some use cases from Kaggle or some publicly available data domain, and I'll try to code and I'll try to show it to you, and I'll push all the code and notebook related to this in GitHub repository so that you can play with it, and even you can try to customize and put these project as a newcomer to your portfolios. It will increase the visibility and it will increase the confidence of recruiter, because I have hired a lot of data scientists as well. I have good experience in this domain. And I have got chance to scan through all over 1,000 resumes while recruiting at different companies, and I find mostly the newcomers does not have many projects, and they would just list out few data science related skills, and but that does not help much as a data science recruiter or data scientist or data science manager at senior level. So your basically the profile looks a bit shallow. So let's begin with the this series. And in this series, as I said earlier, I'll try to code different data science project. Let me share my screen and try to show you or give you a walkthrough of entire project from the business understanding till the model building and output interpretation, basically interpretation for the predictions as well. So let's go, and yes. So this is the project. So first thing is, in data science domain, there are multiple methodology which companies follow to build their solutions. So one of the methodology is CRISP DM. So that is nothing but, if you Google search CRISP DM, it is a data science methodology employed by many companies, and the full form stands for Cross Industry Platform for Data Mining. So basically, it has set of steps from data understanding, from business understanding, data collection till the deployment part, and after the deployment, how you monitor and how you retrain the model. And it has the entire flow, like for software development we have SDLCs. So let's begin with this project. So this project, as you can see, store sales prediction use case. So the business understanding or is there are multiple stores. So there is a basically a store chain, and which has almost 1,000 stores across some region or some country, you can say. And they are like they want to predict the daily average daily sales of stores based on the store ID or a store number. So this is basically the use case. And the how the data would look like is, I have uh, three data set. Basically, one is training data set, another one have been given is testing data set, another one is a store data set. So a store data set will hold store related information, and training and testing data sets are data set with few information about the store. So to begin with the notebook code, you can see few data preprocessing related what do you call imports are there. Libraries, NumPy, you might be aware. Pandas is for data loading and data processing. NumPy is for computations, and datetime is for datetime manipulations. And these are visualization libraries. So basically, everyone knows about matplotlib. But if you want to do interactive plottings, you can try to explore this Plotly Express, which is really cool. And these are, I'll talk about these imports later when in the model building part. Basically, these are some boosting and bagging related models which I'm trying to train the data on. So I have loaded here with the read CSV files, and I have loaded the data, and here while loading the data I am trying to pass the date in some format, which is year, date, and the day, as you can see here. So I have loaded all the data, and you can see how the data would look like with this trained head. If you want to suppose, if you want to see only 4 rows, so you can see only 4 rows. Basically, in head function, you can give different kind of number, how many ever rows you want to pick to just see. So you can see this store. Store is nothing but store number, and day of week is nothing but day of week. Basically, suppose in a week we have 7 days, right? So fifth day is nothing but Friday, and this is the date time, and this is the sales. This is the average sales for store number one, and this is the customer average number of customer which visited a particular store, which is nothing but store number one, and whether the store was open, whether some promotion was going on, or whether it was state holiday, because state was you can see store was open, so there is no state holiday or school holiday. Whether there was a school holiday, still store was open or not. So this is how the data would look like, training data. So if you want to see like how many rows and columns, what are the data types are there in the data, you can just run through this info command and info function basically. So you can see how many rows are there. Almost 1 million rows are there, and how many columns are there. You can see 9 columns, which I have already showed it to you here. So first check is like to see how many nulls are there in the data. In training data set, we don't have any nulls. So these are in percentages. Like if there was some null, then some percentage you would be able to see here. And here I'm trying to see, because this is a store related data. So I just wanted to know what is the date range on which we have the data. You can see the data we have is from 2013 January to 2015 July. And another thing is, because this is sales related data, so I wanted to know whether there are some stores wherein sales are zero. Yes, you can see if you give the sales is equal to 0.0 average daily sales, I mean, so almost 0.17 million rows are there wherein sales are zero. So this is a click, like you need to understand why the sales are zero, whether there was some stores which was closed, or some holidays was there, or some weekdays are there wherein the stores are closed, so sales are zero. So to understand that better, so what I did is I picked a random store, and I just wanted to see how the sales behave. So you can see in this plot, this plot is nothing but every day from 2013 onwards till 2015, we have sales for every day. So you can see sale is equal to 0, red dots are for sale is equal to 0, and green dots are for sale is equal to 1. So to better visualize this, we can go down, and in this picture we can see that this is nothing but January 2013 when sales was 0, and January 2013 second Jan basically sales was there. So it means that some days sales are 0, some days sales are there is basically some average sale values are there. So what are those days? I just wanted to understand that, so I have plotted this figure. So whether there is some particular day like Sunday, store is closed, so sales is 0. The intuition behind this is this. So you can see Sunday is denoted by the color red. You can see in January 2013, 6th of January, basically it was Sunday. Basically it was Saturday. Uh, Sales was closed. and even Sunday, January 13 is Sunday, sales was closed, like store was closed. So it's not specifically, this figure confirms, this visualization confirms that it's not only on Sunday. There are some other days also wherein sales was zero. You can see here also, day of week is 5, which means Friday, but still sales was zero. So it means that not only on some weekends, there are some other days also wherein sale for a particular store is zero. So we need to understand whether, if suppose for this point, if suppose day of the week is 5, it means it is Friday, but it still sales is zero. It means that maybe there was some school holiday or some state holiday. Because of that, it was zero. Now, let's try to dig in another features, which is state holiday. So I just wanted to see what are the values in a state holiday column is there. So you can see values are 0 and A, B, C. So here is the definition for 0 and A, B, C. You can see A is public holiday, B is some Easter holiday, and C is Christmas holiday, and 0 is there are no holidays. So this is a bit skewed in terms of value. You can see most of the data have value of 0. It means that there is nothing, no holidays are there, and few holidays are also there in the data, which is for Christmas and Easter, and public holidays are there. Now here is another thing, another piece of code. Let me explain you with the help of this comments. You can see here in the data we have 0.17 million rows in the number of times different stores was closed. So this many times in entire data stores is closed. So further we need to understand what is the reason. So we can see that these many times, around 3067 times, it was closed because there was some school holiday. Okay, makes sense. It was store was closed, so sales was zero, and there was some school holiday. And itna times, 30k times, it was closed because of either a bank holiday or Easter Christmas. Still, I see that around 0.13 million time those stores were closed on day of no apparent reason. There was no school holiday, there was no bank holiday, nothing, but still stores were closed. So in this problem statement, so we had the liberty of making some assumptions. So I made an assumption that maybe those for those stores sales are zero because it was going through some kind of renovation, and some kind of renovation was going on. They were trying to shut down their stores, and so the sales was zero. And this perfectly explains this use case. Now you can see, so the data for our concern is not where the cells are zero, because I want to predict the future cells based on the data on the testing set. So you can see here, I have tried filtering out or picking the data in the training DF, which is mostly related to where store was open and sales was basically. Okay, I'm trying to drop a column where store was open and sales was zero, which makes sense. Where store was open and still sale was not there, it means that that store is not valuable for me. And so we already know there was no sale, so there is no point keeping those records in the training. So after that dropping, you can still see the data is same, but we don't have data related to store, which was closed, and sales was zero. Exploring the distribution. Now, what I will try to do is, for every single feature, I'll try to go over this and I'll try to see. And basically, this is a part of exploratory data analysis wherein we go through every column, every feature, and try to see what are the descriptive stats and is there anything we can figure out from that. So to begin with this, I have picked the sales column. Sales column, as you know, it have average daily sales for every stores. You can see minimum value of the sale is still zero in some record, and maximum value of the sale is around 4,100 and 41,000 basically. So here I again tried dropping out those records wherein sales is zero and store is open. Even those records is not useful for us. So here is the interactive plotting for the cells. So you can see the distribution of cells. This is the box plot on top of this, and this is the histogram you can see in the box plot. So basically, when we try to analyze the box plot, you see the median value for cell is 6369, and up, and Q3 value, which is 75th percentile, is 8360, and we see that lot of datas are there which is beyond this upper whisker. So you can see even one data point is there where cell is abnormally high on some day. So and mean and median, you can see the median and mean values are mean values basically 6955 and median value is 6369. So here I am trying to see how many times, what is the percentage of time store is actually having big cell day, maybe can be considered outliers, because you see lot of values are there when its cells are really huge. Even upper quantile value, upper whisker value is around 13K cells for a store, but lot of records are there in this region. And I just wanted to check what is the percentage of those records in the data, which is 3.21 percentage. So it is not that significant. So the conclusion for this, maybe large amount of sell on the some days can be attributed to some promotional activities going on, or the store size is very big comparatively, or the popularity of the store is way too much. Sorry. So this is the findings. This is some findings. You can go through it and the comment section for the sales column. Now let's try to see average number of customer. Again, I did the same thing, descriptive stats, where you can see average number of minimum customers who visit to a store is almost around 8, and maximum number is around, on particular day, some stores around 7K people have visited. And so similar kind of plots here, also box plot is there, and some outliers also. I'll not say outlier directly, because outliers has different definition in terms of different what do you call use cases. So here you can see a point which is at very far distance from the upper whisker, and it says that number of average customer is 7388. So maybe again, I was trying to see here what is the percentage of time stores are actually having customers more than usual. Maybe we can consider those a outlier, or is there a percentage of time in the record where the store was having basically no customers. So I was just interested in that point, wherein which is at very far beyond on top of this upper whisker in the box plot. So, and I just took this manually 7,000, where the number of customer is more than 7,000. I found this store. This store is 817 store number, and on this day, sales was really huge, and number of customers were also really huge. So it says that a lot of customers flocked in to these stores, and so the sales values are also more than the average or median value. So just to confirm here, I am just trying to, because there is general notion that if more customer comes to any stores, more number of sales will be happening. So just this is a correlation between customers and number of customers and sales, which is pretty good. Around 82% time it is positively correlated. It confirms my belief that okay, if more number of customers comes to the store, there will be a lot of sales. Now we are done with the training data. So let's do some analysis on stored data, because we have been given this stored data as well. So you can see this is the stored data we have been given. So let me explain you again. It has the store ID and store type. What kind, basically there are few store types also. Maybe I'll explain it later, maybe how many types of stores are there, what are the capacity and all, and what is the assortment. Assortment is some categorical variable here. Assortment, if I say you in business terms, it's like how many types of different goods store sells basically. And this is competition distance. Competition distance is, I believe, in it is in meters, And suppose the store number one is there, so what is the competitor of immediate competitor of this store number one who sells similar kind of thing? So this is it is at 1270 meter, and competition open months, how many months before that competition competitor opened their shop or store, basically that. And this is the year, this is promo 2. Promo 2 is nothing but suppose promotion 1 is going on for some items, and again some another promotions the store has started, and this is the duration in weeks, this is the duration in year, and promotional interval. Suppose some promotion 1 was going on January, and second promotion it started on April. You can see some values in the second row. So this is the data we have. Now again, here I'm trying to check the nulls. Now here's the interesting part. We can see that there are some variables wherein we have a lot of nulls. So you can see in competition distance we have some nulls which is less than 1%. Maybe for those competitor, those store the competitor are far beyond the distance metrics we have set. Suppose we are keeping track of only 5 kilometer or 12 or 10 kilometer. Basically, if it is far beyond that, we don't care. So those data we are not recording. So we have some nulls basically in this, and we don't have this information. Competition open since month and year, so these are nulls. And promotion event promo 2 since weeks, years, we don't have the information. Around 50 or 48% of the nulls in this data. So now here's the part wherein we need to do analysis, feature-wise analysis, and we need to clean this data as well, because our ultimate goal is to predict, to build or train a model which could predict the cells given on the test data. Because in the cells, they'll give you some store in the test data set. They'll give you already. They have given you this store information, and on the test data, it would have some kind of store ID and or other variables also. Based on that, you need to predict the cells. So first thing which I picked here is competition distance. So in the competition distance, I wanted to check how many rows are there wherein we have competition distance of 0. So you can see only 3 rows are there where competition distance is 0. But we need to make a what do you call sorry, we need to make a decision, because we cannot feed our machine learning model with the features which has null value. So we need to somehow impute or remove or do something related to these competition distances where we don't have value. So the first thing which came into my mind is, because there are a lot of what do you call methods to impute a missing value. So here I'm trying to check the distribution of competition distance, and you see distribution is mostly skewed, and we have this a tail at right end, and a lot of value competition distance are very far beyond this. And here the mean, and here the median, and standard deviation, you see standard deviation is pretty huge compared to mean and median. Because this is a skewed distribution, so mean is not a very reliable, what do you call, stats to impute the value. So I have selected here median, though it would make more sense to remove, because we have the pretty good data, almost 1 million rows, and in 1 million, just 3 rows are nothing but it is a peanut. It is very small data we could have removed, but I chose to impute it with the median with this line of code. It is happening that. And now competition open since year and competition open since month, these two variables are there for the time being, because we don't have this information, and competitor have not provided us this information. So I'll try to impute this with 0 for now. And there are other promotion, when the promotion started and we don't have this information for time being, I have filled with 0. So wherever there was null, so I have replaced this with 0, and reasoning is there here. You can go through it, and I'll try to explain it later as well. So now you see there are no nulls in the data, so data is pretty good, in pretty good shape. But again, because this was the stored data, and we did few very basic analysis of the stored data, and we did prior to this we even did a very basic analysis of the training data as well. Now let's join this training data and the stored data, and here we have selected the left join because for every store there are some informations in the stored data. So so we can what we can see, we have done the left join, and now the data looks like this. uh, Data is really, it has increased the number of variables are used. You can see the train store db, I have named it, and it has almost 18 variables, and basically this is a join of training and this data. So now feature-wise analysis we need to do. So the first thing, we have done few analysis on sales and customers, and let's try to pick the store type, because we have right now we have joined the training data with the store data, so we can see a store type. So, store type, before analyzing the store type, so what I have done is I have done a feature engineering. I have calculated a feature called sales per customer to understand, suppose some sales are happening on these stores and numbers of customers are coming to the store as well. So what is the average sales per customer? So this is the feature I'm trying to calculate here. You can see for every store, number of average sales per customer is around 9, 10, and from this data. So this is a feature I calculated. And another feature which I'm trying to uh, calculate based on this is basically this is for visualization. You can see store type A is there, and how many stores are there in store type A, and what are the cumulative sales of that, or how many numbers have visited, and what is the sales per customer for every store type. So this is the aggregated data, and you can see different plots based on this data. So you can see that here are store types. We have almost 4 store types, and the number of stores in every store type is different in different store type. You can see the least number of stores are on store type B, which is only 17, and the highest number of stores are on store type A, which is almost 602 stores. It has likewise, if we can say like in decreasing order, the total number of stores in store type A is more highest, and then comes to store D, and then comes to store type C and store type B. Now, this visualization was number of stores, for number of stores basically. Now this is like about the sales. So what is the sales number for every store type? Again, because large number of stores, the sales type, largest stores is being held by store type A, so there is sales is maximum, then B sales it lowest. In total number of customer who visited is again same for A, because lot of stores are there, so lot of customers are coming, so store type A has a lot of customer visits. Now here is a game, you can see this, you can see, because in all above plot you saw that for everything store type A was more, but why for the average sale per store type is low for the store type A, and B, which has less number of customer, less number of stores, but still you see that average sales is high. So we need to understand this, why the average sales of store type B is high, and average number of customer per store is also high for B, this plot. So maybe the reason could be it has B has only 17 stores, but larger, the stores can be larger hyper branch compared to smaller and more widespread branch of store type A. So this could be one reason. Now you can see average spending per customer in each store type. This is nothing but average spending for D. This is another type wherein a customer comes and they on an average they spend more. Why? What could be the reason? So you can see here both the highest average spending per customer. This can be attributed higher average completion distance. Maybe there are no competitor nearby. So whoever comes and they try to purchase more item, and that way the average sales for store type D is more. Or there is some limited options in the vicinity. So that is the same reason basically. So analysis of the store type has been completed. Now let's try to move to assortment. Assortment is, you can know, assortment is a collection of good or services that a business provider provides to customers basically. So we have multiple assortment types A, B, and C. We can see most of the in the most of the data we have number of different assortment per store type here. So assortment type B has the least number of uh, assortments per store. So you can see most of the dominating assortment types are A and B, A, D, and C. Now let's try to move to promotions, and you can go through all the details which I have put. So now let's go to the promotion. So from the date, I'm trying to extract month, year, and day because we had this days column, and I just wanted to make multiple features based on this days. So we have extracted this, and this is the plot. So how to understand this plot is, you can see, just try to see on 2013, and this is first segment says that promotion is equal to 0, second segment says that promotion is equal to 1, and we can clearly see, and these color codes are based on the promotion 2, if promotion 2 they started or not basically. Promotion 2 0 means that promotion 2 they have not started, and promotion 1 promotion 2, if it has value of 1, it means that promotion has started. So you can clearly see when the promo was when the promo was not there, sales was low, and when the promotion 1 has started, then sales has went up. In the right side figure you can see. But we can also see that there is not much impact on promotion 2, because here you can see in the plot in the orange color it says that promotion 1 continued, promotion 2 has started. So still the sales are not more than the promotion 1. So this is basically some visualizations. Now here comes data preparation. In the data preparation, those whatever I have shown you till now is mostly part of data pre-processing and exploratory data analysis with the help of multiple plots and basically multiple visualizations say you more about the data. So now I'm trying to do some kind of feature engineering. So from the date, and I'm trying to extract basically this is a function is o calendar. It will give you the week of the year, which week of the year, some from the date basically, and the completion open. And we had this features related to completion, right? So it was completion open since year, completion open since month. So I'm trying to use these two features and make a one feature like from how many months completion was open. So this is new feature called completion open, and same thing for promotion open. So how many months the promotion was open. So these two features, and I have placed, if there was some null, so I have replaced those nulls with 0. So this is the distribution of the competition open. So you can see lot of data are there when the competition open is from very long time. Maybe because those competitors are were already present in the market, and it is really they are really very old. And again, in terms of promotion, and we see that a lot of promotions are were going on from running basically from very long time. So original columns I have dropped it related to promotion and competition, and there was another column if you remember called promotion interval. So promotion interval have zero data. Data is basically zero and almost zero point 0.4 million record, and some data we have wherein data looks like this: January, April, July, October. It means that promotion was in January, then it started in April, then it started in July. So, because we cannot keep this data and we cannot feed our machine learning algorithm this data, so there should be some way to encode this data into the numerical feature. So here I'm doing is, so I have hard coded every month in the similar format with some values of month, like 1 for January till 12 month for December. So we are trying to explain this. So you can see this promo interval column, and wherein we have some monthly related information, as I was saying. So what I did is to encode this into some numerical in some kind of number, which is machine learning model, which is expected by machine learning model basically. So we know these months are from 1 to 12, so we have 12 months. So I have just hard coded these months with respective numbers, like January is 1 and February is 2, likewise for all the months till December. So I'm trying to transform that, and basically wherever we see this January and April and July or October, so I'm trying to binarize this column, promo interval. Basically, if we find any month and which is in this month to string, we will replace that with 1, and otherwise if we don't find any month value, basically wherever there are 0, we will replace it with the 0. Where there are some months, so those records will have a value of 1 basically. So this is how I thought to what do you call, label, encode, or binarize the numbers, binarize the values in the this column. So after having done that, we need to understand like what is the correlation in the numerical features, whatever numerical features, whatever pre-processing we have done, and how many other numerical features we have. So we need to understand if there are numerical features which are more correlated than others. So here I'm trying to pick, basically I'm trying to exclude uh, all the features wherein we have any different object type than we are basically excluding the wherever we have the categorical features to hold the numerical data. So this correlation data df, we have a numerical data, and we are dropping this open also, whether the store was open or closed. So this features also we are trying to drop, because that is not a basically, the nature of the column is not basically numerical, it is a binary, like open or closed. So here is how, because we are more focused on only the lower triangle or upper triangle, so we don't really need a heat map with all this value, because diagonal, whatever values will be there on top right diagonal, or basically on top triangle, so it would be a mirrored value. So I am trying to keep the lower value, lower triangle, sorry. So you can see a few, okay, let me. This is the color gradient. So the dark purple color is nothing but zero correlation, and the top yellow color is the highest correlation. So we can see few features are really correlated, highly correlated, few are very low or negatively correlated. So to name some, as we know, customers and the sales, you can see 0.82 are very much correlated, which is very much expected. You can see this 0.82, they are very much correlated. So let me pick some another color for the annotation. Okay, why this color has come? Okay, anyways, so we can see here sales per customers and the promotions also are correlated, because if there are it is business, from the business point of view also it is true. If there are some promotion going on, sales per customer will increase. And here you can see sales versus sales per customer. Here we can see if the promotion is open, the number of customers would visit more. You can see 0.2, and some are very correlated, like month and week of the year. So these are the few of the things which are more correlated than others. So now how to, let me try to remove the annotations. And this interpretation is nothing but basically based on the correlations, whatever we have seen in the heat map, and we are trying to give some kind of interpretations. And this is another column which I tried exploring it, which is a state holiday, and how many type of holidays are there, A, B, C, and then a lot of zeros are there in a state holiday. And so, what I tried doing is, I just wanted to make this value of this column state holiday as binary. You can see here wherever there is zero, because lot of data holds the value of zero, and some state holidays are also there. So rather than keeping multiple category, I'll just binarize it this way. If the value in that column is A, I'll replace with A, B, or C. Basically, I'll replace it one. Otherwise, I'll keep it as zero, and I'll say the column name is state holiday. And I have deleted basically the original column state holiday. Now, there are two columns basically which has multiple categories. One is a start assortment, another one is a store type. So these two column, because we again it has multiple categories and we cannot feed the basic machine learning algorithms with the categorical data. We need to have some kind of number. So I'm what I'm trying to do here with the help of pandas get dummy method is I'm trying to do one hot encoding of these two columns. One hot encoding is a concept which I'll explain in later videos when I'll try to make the video for the ML algorithm. So basically, you can understand here is here in such a way that suppose assortment had four value, if you remember. So assortment A, assortment B, and assortment C. So I think three value only, or maybe I think it had four value, but we have dropped one column because that is redundant, and there is some concept behind it. So I'll explain you why one column was deleted. But so what it says that in the assortment column, if the value A is present, then replace it with 1. If it is not present, then replace it with 0. So basically here in this column, there are in this top 5 record there are no assortment type B, and in assortment type C we have only fourth row wherein we have assortment type C, and this has been done for store type also, store type A, store type B, C, and D. So this all things are done. Now we have done everything, and here I'm just trying to, because U end is when I was trying to get this week of the year with the help of dt dot is o calendar. So it has given a weird like U int type format of data. So I don't want to get into trouble. So later while training the machine learning model, so I have converted this into integer. And here this is all the transformations whichever I have explained till now on the test data, because we in the data we have been given a test data also. So you can see in the here we have three data set: stored CSV, test CSV, and train CSV. So basically this is the test CSV, and everything, whatever transformations and whatever operations have been done till now on the train and stored data will be done on this. And it can be simplified. Basically here we can see that lot of calculations are there and feature engineering are there. So basically this is just a simplified version. And in real world scenario, we don't do this. We can write a pipeline for the transformation. So when the test data flows into those pipelines, all the transformations will be happening, and then model training will be happening on that. Okay. So now finally we have done all the cleaning. We have done all the exploratory data analysis in the data, and now our data is ready for some kind of model building. So here we can see we have dropped few columns, which is number of customers, number of sales, average sales and sales per customer. We are not focused in predicting sales per customer. We are more focused in predicting average sales. Average sales. So I'm trying to drop the sales column as well, because this is the one which I would like to predict, and number of customers also I have dropped. So here is one important thing. You can see this sales variable, which is nothing but our target variable, and these are features, and this is target variable, which we say X and Y. So as the name says, in the target variable we have sales. But when we plotted the distribution of sales, it was looking like a bit skewed. So to be on safer side, I'm trying to do a log transform on this. Log 1p, if you Google it, log 1p is nothing but it is to avoid when the log value or suppose log x is there, and at I think at 1, log 1 is 0. So to avoid that trap, I am trying to use log 1p. So basically it is transforming this sales data into logarithmic scale and recording it into the white target. So now the thing is, we have the training data ready, and to build the model, one necessary step is to split the training data into training and testing set. So with the help of scikit-learn train test split function, I am just feeding this x and y like features basically in the target, and I am setting this test size is equal to 20. Text size is equal to 0.20. It means that in the training set, how many of our records we have in total data, 80% of that will be allocated into training set, and 20% will remain in the validation set. So as the and this random state is equal to 42 is just for the reproducibility of the code. So here we can x train and y train, x validation and y validation. So basically I'll be training my data on x train and y train, and I'll try to validate this the performance of the model on x validation and y validation data. Here is a simple function which I have written to get a root mean square error and r square, because this is a regression problem, because we want to predict a continuous value which is sales given the data. So for the regression model, I hope you are aware that the metrics to evaluate the model is RMSE, R square, adjusted R square, MSE, MAE. Based on different business scenarios, different kind of metrics you can use. So right now here I'm trying to use RMSE and R square, and I'm trying to print this. This is the function. Just to ease the evaluation process, I have defined this function here. So the first thing, randomly, I started with random forest regressor. Why random forest regressor? Means this question will come to your mind, but the reason, simple reason behind this random forest is it is a tree-based algorithm which does not care much about the categorical variable, or if you have missing values in the data, and it is basically it tries to combine many weak learners. Basically, different decision trees will be trained on some samples based on the bootstrap aggregation concept, and finally the average of, in this case, because this is a regression problem, so for all the predictions will be taken from different trees, and finally the average will be the final prediction for every record. So basically this perform better in most of the situations. So I have randomly taken this estimator like number of decision tree 8, and maximum depth of the tree is 8, and sorry, number of estimator 100, maximum depth 8, and verbose is just for verbosity to see the progress basically. And number of n jobs is equal to -1 is for parallelism. Basically it tries to use all the cores in your machine to train the model, and that way it is a bit optimized, and it is a bit faster. So first model which I trained, I was trying to get the prediction on the validation set, and you can see model evaluation function I'm trying to call, and the model performance is very poor. So it says that root mean square error 2491. What does it mean? Root mean square 2491 means that on an average, for every store, the fluctuation in the prediction on every average cell is 2491, which is very poor. So you cannot have this much fluctuation in the sales. Your model is performing below average. Suppose you are taking averages, like you can say, okay, the sale can be just a average. You can average out on different stores and you can give that value. And this model is performing worse than that. R square is 0.36, is like our model is only trying to pick 36% variance in the entire data, and this is really bad. So here I decided to do some hyperparameter optimization with the help of, a grid search or random search. Here I have used random search with, and I have basically hyperparameter optimization is nothing but trying to choose which parameter, what value of the parameter would be best for our model, and what is the best model. So here maximum depth parameter, I am using multiple values, and number of estimators also I am using multiple values, and minimum sample is split. So this is nothing but a feature in decision tree split, wherein it would decide that okay, it would only split if only two samples are there in a node. So and then here we are choosing K4 cross validation, wherein if K4 cross validation value is 10, it means that on 9 of those folds training will be happening at some point of time, and the 10th one would be used for evaluation. So continuous training and evaluation will be in process, and this is finally great that best parameters it will give and best scores it will give. So after having trained this, because it takes a lot of time, so I have commented out this part of the code. I found that number of estimator optimal with the optimal performance was 128, maximum depth was 20, and these parameters are default. And again, based on those important parameters, and I'm trying to evaluate the model. You can see now this time it is R square is 84%, which is really good, and it is a huge improvement, you can say, over 0.36. And still we see that average sales prediction is off by 1200. So I decided to go ahead with some other kind of algorithm. So we were trying to play with bagging algorithms, ensemble algorithms, basically random forest. Now I have moved to boosting based algorithm, which is nothing but XGBoost. And this is the first one I tried using it. You can see number of boost route. I have set it really huge, and this is basically syntax, because XGBoost is more optimized for D matrix kind of structure. So I'm trying to transform this Xtrain and Ytrain in dtrain, D matrix format, basically renaming it dtrain and D validations. So this is watch list, nothing but the training data. And here is the training part of this. It takes a lot of time, not lot of time, I think it takes 10-15 minutes. So early stopping round is 100. I have set it like if the performance of the model is not improving after 100 iterations, then we can stop this, and we will report the final stats. So you can see after having done this, and our model is performing really cool here, around 96%, and the offset is only 592 in terms of sales, daily sales, which is really good. And we have been able to improve from 36% of like 0.03 point 36 R squared till 0.96, which is 96% of the variations in the data is explained by the target variable, which is really amazing. So the predictions from this model would be really good. So this is the final model I have chosen, and here you can see what are the important features, because here is some kind of functions we have in XGBoost, which tries to plot importance, and you can see this. Day is very important, promotion open is very important. So these are the features which was important. So here is a way I have tried to because I have, for this small project, I have played with only 3 models, and here you can see the performance in terms of RMSE and R square for different models. So the final model which has been selected here is XGBoost regressor with 0.96 R square value. Now, in the training data set, we already know average daily sales value. So I'm just trying to get the prediction from this model and rename it as a predicted sale. You can see in this data, just a glance of that. Original sales was 5263, and the predicted sales is 5309. So for almost all these values, sales values, predicted values are more or less very close. So it means that this model is really good. And now, because we know that model is good with good accuracy, basically not accuracy we use in terms of classification. Here we can use the term R square or RMSE, sorry. So in the testing data, I am trying to get the predicted sale value, because we did not have the sales value in the testing data in the original data set. So I have appended for this test data, I have appended the what sales value would be for these stores. store number one, store number three. You can see um, because the data was till July of 2015. Now we are trying to predict in September 2015 what would be the daily average sale for store number one, or for store number nine, what would be the daily average sales. So this is the sales prediction. So finally, after doing everything, and we are trying to save this, because we have appended this predicted sales, and we are trying to save this in CSV format. So this is the end of this project, and you would be able to find this project because I have done all this. Notebook would be available on my GitHub repository. So let me show you my GitHub repository, and I have not posted the uh, codes till now, but I would be doing it very soon. And all the descriptions you would be able to find on the um, my YouTube video description. and and with this, I'll stop sharing my screen. Yeah, so this was a very small project, and wherein I have already explained entire projects where this is related to daily sales prediction for stores, and I'll be coming with multiple projects in different domains, and you will find the video in my YouTube channel, ML with Munazir. Please feel free to like, subscribe to my YouTube channel, and try to share my videos. And please follow me or search me. And I'll give my LinkedIn profile link in my YouTube channel, and you can try to write me in LinkedIn message as well. So thank you very much for joining the session. Thank you.